In this video, I'm going to talk about governance fuzzing with Recon Pro. Governance fuzzing is a pretty advanced tool that allows you to run a new job whenever an on-chain event happens. And not only can you effectively trigger a CI/CD by listening on chain, but we can also test against that specific block and perform dynamic replacement of some parameters that we fetched from an event that triggered that specific test. So in lack of you setting up monitoring and using our API to trigger fork testing with your own logic, governance fuzzing effectively does that for you. I'm going to show you a slide from a talk I gave at ETH Belgrade, which shows you the architecture. We effectively have a matcher, which is the event that we want to listen to. So we have a server listening to these events, and we're going to define it in a moment. Then we're going to have the processor, which will interpret this. That's also something we're going to code together. It's not as difficult as it sounds. We're going to use dynamic replacement, which we have a separate video for, but I'm going to briefly talk about in a moment. And then we're going to effectively use your invariant testing fork test suite with corpus reuse in order for us to very efficiently test against these updated state. So when it comes to dynamic replacement, we are effectively going to have a setup that looks like this. We're going to have some sort of a variable called, in this case, initiative to test, which has the address 0. One of the prerequisites of the dynamic replacement is that we have the type wrapping the value in at all times. That's just a technical limitation, but like the code compiles either way, whether you add it or not. But fundamentally, what I'm going to show you is the idea of us having a suite for a contract such as the Liquidity V2 governance, where you can register a new initiative and say that for each new initiative you want to run the same type of invariant tests. But obviously you don't know the code of the initiative because the initiative has to be registered. So instead of you calling us the day after and us setting this up, I'm going to show you how this can be done fully automatically thanks to governance fuzzing. So when the register initiative is called here, we're gonna the contract emits this event that shows you the initiative as this address. And so our job is to use effectively dynamic replacement on this initiative to test so that the initiative to test is replaced to whatever address we get. And you can see that down here, we're gonna have the demo replacement done. And now we're actually gonna set it up so that it works on chain. So let's grab the event definition here, event register initiative. And let's say that this is the address, although we can probably grab it. But the next step is to choose the chain, which I'm going to choose Ethereum. And then the recipe consists of a recipe where ideally you use Echidna in a fork state with corpus reuse. But fundamentally, you can use both Echidna and Foundry. In this case, I'm going to pick this Echidna recipe. And then I'm going to simply add the event. I'm going to have an issue here in parsing it because an enum needs to be casted down to a uint8. And then now I basically parsed it. And so just to show you the most basic version of this will be to mark all of these parameters as unused, meaning we don't care. And so we're just going to listen to this topic on chain on that address. And effectively, we now have set up CI/CD of our fork testing against an on-chain event. We don't test against anything custom, but as it stands, we will basically trigger a new job whenever something happens. This can be useful for contracts for which you want to maintain some sort of a state integrity invariant. We have other solutions as well. One of them is called stateful monitoring, but governance fuzzing effectively is the most advanced version of stateful monitoring because not only you're going to fork and run assertions, but then you're going to run the fuzzer against that fork state with the goal of breaking it. And so to make this even better, what we will want to do is we will want to replace the initiative. So the first parameter of the event is this address. So I'm going to grab it. And then as you can see here, it's pre-filled by saying, address constant payload is equal to an address with two x's. In our case, we don't need the address, or rather the variable is called initiative to test. And so I'm just going to paste it in this way. And then I'm going to add back the XX, which in the context of this UI is telling the UI that this is the value of the event. this internally gets replaced to $0, which is basically the first parameter. So you have to be very mindful of casting and want to make sure that it works. However, if you were able to run a job with dynamic replacement, then this is just dynamic replacement that is triggered by an event. If you need to experiment with even more advanced workflows, we have API access, so you can actually set up as advanced workflows as you want. However, we provide governance fuzzing out of the box because we believe it is the most far way for you to monitor your contracts. So at this point, we set up this code and we even check that it will compile. And then you can see down here that the payload has been updated. This parameter is used, everything else is unused. So now to preview that it's gonna work, we can just grab our setup file and we can basically verify that if we had a value of T or $1, then that value will be replaced. So the next step will just be to confirm, and then you will likely want to trigger the event to debug and make sure it will work. And fundamentally, if you do this with a properly set up recipe with alerts, you now have effectively created the most advanced way to predict if something is going to go wrong.